This is Unson, and for the final review problem, I'll be doing question number 26 from 13.1. It is a domain and range problem. For this problem, they want us to find the domain and range for f of x, y equals the square root of 4 minus x squared minus 4y squared. First step in this problem, as we normally would do, anything underneath the square root has to be greater than or equal to 0. So we can set 4 minus x squared minus 4y squared has to be greater than or equal to 0. What I'll do next from here is shift the x squared and y squared to the other side, because when I look at it, I see that it's going to become an ellipse eventually. So to put it into ellipsis form, we get 4 is greater than or equal to x squared plus 4y squared. Next step, because ellipses need to be in equal to 1, we're going to divide both sides by 4. And when we divide both sides by 4, we get 1 is greater than or equal to x squared over 4 plus y squared. Now, for continuity's sake, to be able to show how big the radius is, I'm going to put this y squared over 1. And then I'm going to rewrite it so that we get the x squared and y squared on the left side of the equation. So that gives us x squared over 4 plus y squared over 1 is less than or equal to 1. This equation will represent an ellipse that is 2 units wide and on the sides and 1 unit tall from the radius up and down. And now if we look at this, we're saying less than or equal to 1, which means inside of it. And now to check that, we can plug in a value that's inside. A fairly easy value to plug in would be 1, 0. And if we plug in 1, 0, we get 1 squared over 4 plus 0 squared over 1 is less than or equal to 1. That gives us just 1/4 is less than or equal to 1, which is a true statement. So being inside does work. And then of course if we were to go and check something outside, it would be an equation that doesn't work. So to do that, we could pick the point 2, 2 would be outside. It would be about right there. If we were to plug in 2, 2 to our equation, we would get 2 squared over 4 plus 2 squared over 1 is less than or equal to 1. This gives us 4 over 4, which is 1, plus 2 squared is 4 over 1 is 4. It's less than or equal to 1, which gives us 5 is less than or equal to 1, which is a false statement. So that there confirms that the domain is the area inside of this ellipse And now to move on for the range of our function. Now, for the range, we just have to do a little thinking here. So, because nothing exists, because you can't have a negative underneath the radical to stay within the domain, that means that the smallest thing we can get, smallest value we can get, is 0 underneath the radical. So, our smallest value we could get, which would happen anywhere along the curve of our ellipse, the edge of our ellipse here, gives us a 0 value. So that 0 value is our low end of the range. And it is 0, it's not approaching 0. So we use square brackets there. And then on the high end, because those are both negative values, because of the negatives, and they'll always be negatives because the squares prevent negative times negative from making a positive there. We get the largest value you can have is radical 4, and radical 4 reduces to 2, and it will be exactly 2 at the origin, when 4 minus 0 squared minus 4 times 0 squared gives you radical 4. So our range for this function goes from 0 to 2. So now for some visual proof of the exercise problem that we just did. Let's graph the square root of 4 minus x squared minus 4y squared. So the graph that we have here is the ellipsoid dome, and as you can see here, our range goes from 0 to 2, and the oval is the same one that we drew out. The area is inside. If we hear control home here, we see that it's the inside area of an ellipse that is 2 wide on each side and 1 tall on each side. So there's just some visual proof to go along with the problem that we just did.